Okay, so here for our next definition, we are going to define something relating to these three graphs that we just saw. We're defining something called a critical point. So a critical, whoops, let me write that a little smaller, a critical point. Or I think the book also calls these critical numbers. So a critical point or critical number of a function f is a number called c that's somewhere in f's domain where either one of these two things is happening. Either the derivative at that point c is equal to 0, or the derivative at that point c is undefined. Okay, so f of c equals, or sorry, f prime of c equals 0, big difference there, or f prime of c is undefined. So you'll notice that this idea right here, f prime of c equals 0, that was the key to finding these absolute maximums and minimums in the previous three pictures here, where we've got these green highlights and the horizontal tangent lines, because remember, horizontal tangent line is where the derivative equals 0, because that's the slope of the tangent line. So this is just talking about a horizontal tangent line. Okay. And remember, if your derivative is undefined, there's a couple things that could cause that. Vertical asymptotes, vertical tangent lines, discontinuities. But notice that if we're going to combine this idea, f prime being undefined, with the previous theorem, like the extreme value theorem here, if your function needs to be continuous and you're looking for a place where f prime of c is undefined, that is mostly going to come up as being sharp corners or cusps on the graph. Okay, so remember those looked like this type of thing. You could have a sharp corner, like maybe an absolute value type of situation that would come up there. Or the cusp was like the really sharp idea, like this type of thing. That's a cusp of a function. And so you could see for those two little pictures there, where the derivative is undefined would be like right at the top of that peak or right at the tip of that cusp. And so those would give us some like little extreme values as well. Those could be absolute maximums, or those could even be maybe local maximums there as well, depending what the rest of the function is doing. So yeah, we need to also consider those points where f prime of c might be undefined. So yeah. So collectively, where the derivative is 0 or where it's undefined, those are called critical points or critical numbers. Okay, and that's where our local maximums and minimums are going to be. So this, notice how it is local now, local max and min values. So local maximums and minimums are going to be located at those critical points. Okay, so these are at f of c, where c is a critical point or critical number. All right, point slash number. Yeah, again, I think the book calls them critical numbers, but when I learned it, I called them, our class called them critical points, so it means the same thing. Okay, So this is helpful for both locating absolute maximums and minimums, okay? Because that might be like these horizontal tangent line situations, you know? Or maybe a very steep, sharp corner or high up cusp, something like that. So they're good for absolute and local maximum and minimum values. It's pretty nice. So these critical numbers are going to be, well, critical to doing problems correctly. So we're going to need to know how to find those. And the next part here is looking at a series of steps to help us find the absolute extrema on an interval. So notice we're back to absolute here. So it's kind of switching back and forth between looking at absolute, local stuff, absolute again. But notice now that we are going to involve the critical points of our function. So if we have a problem that wants us to find the absolute maximum and absolute minimum of a function on some interval from A to B, we're going to start out by finding these critical points. So we're going to need to take the derivative of the function and see where it equals 0 and also where that derivative is undefined. So we'll find these critical numbers C. Okay, there might be more than one of them. And we'll see, you know, which one of those critical points are actually in our interval. And then we'll find the value of the function at each of those critical points. And then we'll also look at the two endpoints. Okay, so critical points and endpoints here, because these are absolute maximum and minimum. So we could have any one of these three scenarios. You know, you could have it just at the endpoints, could have a mix, could have them both at critical points and nothing going on at the endpoints. So we want to cover all of our possibilities there. So you'll look at your values of f at each critical point and the two endpoints, and then you will compare those values of f from step 2. The biggest value of f is going to be your absolute maximum, and the smallest is going to be your absolute minimum value. All right, so I'll stop the recording for a sec and then we'll go look at an example of this.